In this video, we're going to find what's called a local linearization. That's where we take a function and we come up with an approximation to that function. Now, we've actually been doing this before. The name that we've given this process is finding the tangent line. And that's really all we're doing in this example. We're just calling it by a different name. But this is a formula that you can use to find a tangent line or a local linearization. Please note that what you need is you need a point A that you're focusing on. You need the value of your function at A, and you need the value of the first derivative at A. So let's do an example with this function. What we have is that A, the point we're interested in, is equal to 0. That's what this piece of information is giving us. Alright, I need to know what f of 0 is. That's the square root of 1 plus 0. That's 1. Now I also need the derivative. So f prime of x is going to be the derivative d dx of 1 plus x to the 1/2 power. Of course, we're going to rewrite this using fractional expressions. Yay! This is chain rule time, because notice that I've got something complicated in the parentheses. It's not too complicated, but we'll go ahead and use our z's. And so what we're going to get, using the power rule here, is 1/2 z to the negative 1/2 times the derivative of this function, which is just 1. We've got to plug in z, so this is 1/2 1 plus x to the negative 1/2. And you might, this time, think about rewriting this just a little bit. Because while this form is nice for taking derivatives of, it's not the greatest thing to plug into. So you might want to rethink of this as 1/2 times 1 over the square root of 1 plus x. So that means that f prime of 0 is going to be, well, I'm going to plug 0 into that, 1/2, 1 over the square root of 1 plus 0, that's 1/2. Yay, we've got all our pieces. We can put together our local linearization. So f of x is going to be f of 0, which was 1, plus f prime of 0, which was 1/2, times x minus 0. So that's just 1 plus 1/2 times x. Now you can always check this. I'm going to check this by calling up Maple. Here we go. So here I am in Maple, and you notice I've, instead of using the square root little symbol, I've just typed out sqrt for square root. And let's plot this around x equals 0. So let's go from negative 1 to 1. Yeah, that's exactly what we want to see. That's how we know we've done a good job. We were trying to find the local linearization of our red function, the square root function, near x equals 0. And you notice that we have got a beautiful tangent line here. That is always a good check. And if you're unsure about your answer, I would advise that you do this on Maple, on Wolfram Alpha, or on your graphing calculator.